All right. Assalamualaikum and very good morning to all the participants in this session today. Uh, we would like to start the seminar today. It's scheduled at 9:30 until 11:30. Thank you so much making time on this Saturday for this session, and thank you to our speaker, Mr. Hua Chongji. I hope that you can see our screen now, and I hope that you can hear the voice. If you have any problem or any questions, you can post it in the chat box. So currently we have about 155 attendees from the student side. Suppose we have about 450 still waiting, they are coming, and the number is keep on increasing now. Before the session, I hand over the session to the Mr. Should I call Mr. CJ?
Yes.
All right. I would like to introduce Mr. CJ a bit based on the CV that I have now. Mr. Kwa Chongjing, with his nickname is as Mr. CJ.
Yes.
He's a founder of New Meat Engineering. So you are the owner of the New Meat Engineering. He is working with previously. Mr. CJ is working with Toyota Production System before start with his own company. He has a broad experience in the FEA, and he has completing many cases project exploring different engineering discipline, especially when he involved with his major field, the application of computing fluid dynamics, CFD, if you are familiar with the CFD, and finite element analysis via benchmark, technical training, and consultation work and etc. Beside that, he also has his own main duty explore different business opportunities such as e-commerce, beside from the finite element area. Also, he has his own website from an open source engineering, which is called as www.onlinestore.newmeat.com.my. Exportation of a bird nest product and branding consultation. And then database software development for CRM and inventory management. And he's currently developing an interface to manage open forms, process, and data. Actually, I'm not that familiar with the word. It's open forms. It's my first time to hear
Yes.
about it.
OpenForm is open source CFD software.
All
So
right.
it doesn't have any user interface. It doesn't have any button to interact with the software. So the user has to put in the command to operate the software.
Okay.
Yeah.
So the software name is Open Forms.
Yes. OpenForm.
Okay. So it's an online
Yes.
software.
It's a open source free software.
Okay. It's great. I think that's all an introduction for Mr. CG. Without any further delay, I would like to explain our schedule for the seminar today. Mr. CJ is going to present about 2 hours, and after the presentation, and even during the presentation, if they have you have a question, you can drop the question at the chat box. And after the session, we are going to discuss about the Q&A from question from your side. I think to Mr. CJ, currently we have attendee about 238. Still keep the number still keep increasing.
Okay.
And so you can start the sessions.
Or should we wait? We will start our presentation and short training right now. And thank you everyone for attending this short training. And I believe that today is a good holiday for you all. First of all, I would like to thanks to Dr. Shakia for organizing this hosting this WebEx with Mr. Rizwan. And I would like to thanks to panelists as well, Dr. Adizaz and Dr. Anizayati. I hope I have pronounced your name correctly today. All right,
That's
so
correct.
okay, that's good. Okay, no worry. This I believe this WebEx will be recorded, and for those who have entered this WebEx late, so they will be able to view the videos. So either on this sharing by Dr. Shakir, or I will be uploading as well in this our website, the academic.newmeet.com.my. Okay, so just treat this training to be um, you know, just holiday sessions. Everyone is going to be very happy. It's not just a course, just 2 hours. Okay, so first of all, I just would like to turn off my video. Hopefully that make sure that the screen is streaming smoothly. All right. Again, good morning, everyone. So today we'll be focusing on a BEAM-TRUSS modeling with the midasNFX. It's a FEA software, finite element analysis software. So I'm not sure how many of you have already exposed to finite element software, and I believe some of you who heard about FEA, so they are going to afraid that it's difficult to use, it's difficult to set up. All right, so well, you don't have to worry about that. So as long as you follow the right procedures, as long as you follow the right process, there should be no problem. All right. So of course you need to have your fundamentals knowledge, okay, about mechanicals, about the seals, about the structures, and etc. All right. So that is the reason why the software can only be used by most of the engineering students or engineers. And because of this reason, we have also developed Midas NFX to be able to be used by a draftman as well, right? So which means they may not have any education background on mechanical or civils, right? But they have a knowledge on how to draft, how to design, so they can use Midas NFX as well. So we have actually two different modes in the software itself to help the user to utilize the software for finite element analysis. Okay, so I'll be going to the next slide and just turn off this. All right, so I would like to make a short introduction about Numi Engineering. And first of all, my name is CJ. I have a mechanical degree background on these structures, on the fluid dynamics, right, on all mechanical stuff. What we are focusing and doing right now, so we are serving majorly in the engineering, so which focusing well, engineering is a big field, is a large field. We're focusing in this virtual design by using CAE, which represent the computer aided engineering. This CAE basically has two different type of software, which is the one that you're going to explore today, the FEA, finite element analysis. FEA is actually for structural analysis, and we are doing also on CFD, which is computational fluid dynamics. So it's for the fluid itself, and it's for the gas itself. All right. So I think you have fundamentals about the elements in our universe, and we have gas, fluids, and structure. So we are actually trying to develop a software that is to govern the universe equations, right? So which we are going to focus today on finding the element itself. So the CAE software can be used in many different area, right? So for example, like R&D, like what you're doing in your final project, your thesis, your master or PhD project. It is used for most of the industry for developing their product, right? Without doing testing. Yes, they initially they have to do testing to compensate with the result by from the simulation itself, right? The reason why they would like to shift the testing into the simulation is because of the cost. The testing cost is always huge and larger than simulation. So, and the second reason is that with simulation, you will have a very fast turnover design compared to testing, where testing you have to prepare your rig, you have to prepare your jig and testing equipment and etc. You have to make some few tests before you can finalize with a good product. And CAE is also used in product D&D as well. So what is D&D and what is R&D? So R&D is somewhere you doing some research and refine your design, and product design and development is not involving in research, right? So they just improve the design by using testing method, try and error, right? So they can use it for simulation, for try and error, or testing as well. So we are focusing on lean manufacturing system, where the manufacturing occur to produce some products. Okay, so we try to study and increase the productivity, or so-called the efficiency of the manufacturing plant. Okay, so I'm going to skip a little bit here. We also focus on Bernes product. We also focus on e-commerce, and both um, area we have developed our own website as well. And lately we have launched our new website, which is the academic.newmeet.com.my, where you can explore a free course in FEA, in CFD, and all related courses. So just skip this one for a moment. So this WebEx will be recorded, and I will be recording on my side as well. And after the training, you'll be able to find it as in this website, academic.newmeet.com.my. All right, so what you have to do is you just log in, all right, and search for the course that you are interested. And one of the course today will be uploaded here as well. We have related FEA analysis, like design simulation with seismic analysis. We have FEA courses in simulation. So these are all free except for this one. All right. We have CFD analysis, we have thermal analysis, and etc. Okay, so for this course, I'll be uploading and make it free for you all. Okay, just make it a little bit quick. What we are, so we have a few clients already in Malaysia for CFD and FEA analysis. For FEA, majorly focused in oil and gas. We have CFD as well. For example, like TMB Research, they are using our CFD and FEA both for their application as well. So beside that, we are doing quite a number of activities beside providing the training on CFD or FEA. We also build our own software for database management system, for CRM, for which is called customer relationship management, and etc. And in the engineering field, we focus with our partner. We work with our partner, right, for distributing the software, for distributing the training. For the training and the support, major is done majority by our own in Malaysia, right? So you can see from the left top here, we have SimFlow together with OpenFOAM. It's an open source CFD software. On the left, we have Numeka, so it's also the CFD software as well. You might familiar with midasNFX, which I promoted a moment ago. Siemens. Siemens has a very large application from the testing up to the simulation itself. We collaborate with them for simulation area. Fraunhofer. Fraunhofer is a simulation. They're developing some simulation software, but they are more on to multi-physics. So these are the summary about the company from different worldwide. Numerical from the Europe, Midas, the software that we are going to use today is actually from Korea. Fraunhofer from Europe as well. So and etc. So these are our few of our client in automotive, construction, aerospace. electronics, general equipment, from institute, and from medical industry. So FEA and CFD both can be applied in most of the discipline. Okay, not only in civil engineering, not only in mechanical, but also in aerospace, in medicals, and semiconductors, and etc. Right? So these are our local clients who use both our software, and these are our experiences in working on different cases in different discipline with different industry and university as well. So I'm going to skip this. All right, so today we'll be focusing on the truss beam frame, all right, using finite elements. So I was informed that most of you do you do not have any fundamental of FEA. So what is about FEA? What is so difficult about FEA? So FEA is is something that is not difficult. It's not complicated. Um, if you have, let's say, for example, let's go back to calculus. If you have a differential equation, I would say that something like PDE, like partial differential equation. So how you're going to solve it in our engineering activities. So you're only using by integration, you're going to use it by a different method of interpolation and etc. So I believe you have heard about the discretization of the partial differential equation, whereby you're going to convert the original PDE, the differential equation itself, back to back into the differential method, which is the when we start to define the differential equation from the Newton conception, right? So if you remember that we set a limit when x approach to 0, right? What happened to the whole function itself, right? Before we converting the real, converting into the differential equation, right? So we are going to work backward in this case. So which means the f final minus the f initial divided by the delta x. That is simple as that, right? So the delta x represent the space in our 3D dimension, the x-axis. So we are going to build it in the 3 dimension axis, which is delta x, delta y, and delta z. So you don't have to define any equation in the software. You don't have to deal with any equation in the software, but you need to have the fundamental about the civil engineering, the mechanical engineering, and etc. All right. Okay, so today we'll be going to work on truss beam frame. In finite element analysis, the process is very simple, where you need to have your own CAD or your own geometry. It can be developed from external CAD like SolidWorks, AutoCAD, Inventors, all right? So whatever CAD you're trying to do, it can be imported into the FEA. All right, so there are a few format about the file format of your geometry can be imported. For example, Midas can import directly from Autodesk Inventor, can be imported directly from SolidWorks, Katia, and etc. Right, so you don't have to deal with Midas FEA. So, however, for myself, am prefer to build the model within the Midas NFX. Midas NFX is equipped with this CAD drawing as well, which you can generate 1D drawing, 2D drawing, up to 3D drawing without any problem. All right. So with this truss and beam, you'll be seeing the dimension like we have 3 meter high, we have 10 meter width, so we have 2.5 meter in between these two thrusts. Okay, so at the upper thrust, we're gonna have a 5 meter. So we are going to build using a wire. So means that from the bottom here, we're going to sketch wire. Wire means it's similar as H, all right? So just sketch over here, and we will assign the properties to each of the wire, saying that this wire belongs to I-beam, and this wire belongs to the pipe or the tube itself, right? So when we are activating, switch on the properties, you may able to see the visualization of the real geometry. right? So what will be the difference is that we are not dealing with the real geometry in 3D, where we are not going to build the beam in 3D like what you are seeing, and we are not going to build the tube in 3D, and these are the tube you are seeing here. So we are going to use 1D properties. So what will be different? I'll be showing you in a moment. All right. So once we have the model ready, we are going to assign the FEA properties. So in the FEA properties, basically, for example, like the matrix itself, the mesh, we're going to build the mesh, and we are going to assign the constraint. We're going to assign the boundary condition, which mean like constraint, we're going to fix at which point, right? We're going to assign the force as well. So in this case, we are going to apply two type of force. One type is called the point force. We are going to apply the force on the point itself only, right? And we are going to apply the force, the second type of load, for the beam load, right? So that is going to be demonstrated. All right, so we'll be going back to our software. Okay, before I start with Scratch, so this is the final result you're going to see. So this is the midasNFX. I'm going to start everything after that, but I'm going to show you the result first. So as I mentioned that we are using 1D properties, and we have 3D as well, but today we will be dealing with 1D, because most of the truss and beam is preferable to be designed in 1D. Okay, there are many reasons of doing that, right? So you can see the beam and the truss. Okay, so this is just for visualization. So in our real sketch, there will not be anything like this. It's only something like this, right? But if we assign already the properties to the wire, so the solver will handle mathematically, and based on the I-beam properties, based on the pipe properties, to calculate the stress, strain, the bending moment, and etc. Okay, so I'll be starting a new one. Okay. Okay, so this is the FEA software. This is the Midas NFX. So what we are going to have here is a very simple things. On the top, like geometries, you can import the geometry from your to the CAD software. All right. I'm not sure which CAD software you're using, so you can import a universal file format. All right. So if it doesn't listed here, so you may export into like Parasolic, the .x underscore t, the ASCII file, the stat file, the IGES file. These are four universal file format which most of the CAD software can export. You can even try to sketch over here. So I'll do the demonstration over here. You can have a point sketch, you can have a curve sketch, you can extrude, okay? You can create a surface and etc. Okay, so these are the step of doing the FEA. So the second step is you're going to assign the property and the mesh to your model, and sorry for that. You're going to assign the boundary condition. So it depends on the boundary condition or the analysis you're going to do. All right. So in our case, we are going to do a static analysis, which means the load is actually a static, is not a moving load, it's not a dynamic load. So we are going to use some of the parameter over here. If you are doing for the crash analysis, if you're going to for drop analysis, or anything that is vary in terms of time domain, so you'll be using these tools. And you are seeing that the CFD is over here, the computational fluids dynamics. So you can also model the fluids over your model as well. Okay, so the rest will be running the simulation and post process your result. So overall, if you have already exposed to introduction about CAE, either computational fluid dynamics or finite element analysis, it composed of three sections of the software. All right. The first section is the pre-processing, which include the geometry and the mesh, where you prepare your geometry, you import your geometry, you create the mesh or you generate the mesh that belongs to pre-processing. All right. And when you set, of course, you set up the the boundary condition as well in the pre-processing. When you are done, so you'll be running the solver, you'll be running the simulation. So you will be calling out the solver itself and solve your the setup, okay, all the parameter involved. So that is in the solver section, and we have post-processing, which is the result. So how you're going to display your result, how you're going to post-process your result. So these are three terms we usually use in CAE for CFD or FEA: the pre-processing, the solver, and the post-processing. All right. I hope I have I'm moving slow for you, and not any one of you have problem, just raise your hand. um, no worry again, so this video will be recorded and you can rewind to revise your modeling, right? Okay, so first of all, it is important for you to start with the grid size and also the Cartesians. All right, so you have to know where is your direction, where is your x direction, where is your y direction and z direction respectively. Okay, that is the first thing. The second thing is you have to know what are the units to be used. So on the left, on the right bottom, you may able to see we are using mm. We can use meter as well, we can use inch as well, right? So these are the main unit that we are using. Okay, so I assumes that our gravity will be acted in the z direction, right? So, well, you can assign the gravity to be acting into the y or x direction, but I prefer to use and refer to z-axis, right? So I'm going to build the truss and beam with respect to the z-axis. So what I'm going to do, in order to make a sketch over my midasNFX, and you are seeing the grid, right? So whenever I make a sketch, it will always on, okay, let's make on 2D, it will always fall onto the grid itself, all right? So let's say I have a circle, it will fall on the 2D on the grid itself. All right, so just undo. And if we back to our presentation, I'll be using a z-axis to represent our vertical direction. I'm going to switch and move this grid into this direction. Okay, so it's up to you, right? In my practice, I prefer to use z to be my vertical axis. It doesn't matter. All right, so the second thing is the selection of your grid size. So how do you know that what is the grid size you're going to use and what is the current grid size? Let's measure. I'll be using this measure distance. So this is about 800 millimeter. All right. So let's back to our presentation and let's see the dimension. So we are going to have 10-meter width, right? So the maximum is 10-meter width. So 800 mm definitely and obviously it's not fitted into our geometry, right? So we are going to increase the size. Since that we are using meter, so it is convenient for me to switch to meter, and we are going to increase the size here. So the size of the grid is 0.02 meter, which represent this. All right. So let's increase about 5 and see what's happened. So we zoom out. Okay. So let's check 20 meter. Right. I think it's good enough. or maybe we can reduce as well if too much. Perhaps let's try on 0.1 and zoom it up. Okay, so the zoom in, the zoom out is just using your mouse, either on the button of using the button of the scrolling. Okay, so we have 4 meters, so that is not enough. So let's put a little bit higher. Let's put 5. Okay, so I believe this is a good size that we can book on the scratch. Okay, 20 meter will remain the same. All right, so let's see what we have. We are going to have 10 meter and 3 meter. Let's start with 10 meter perhaps. Let's start with somewhere. I think this is about 10 meter. That's good. Okay, so let's select on 2D so that the line will lay on our 2D. All right, and let's turn off our grid and the reference datum. Then you should see the line for diameter. All right, okay, so let's align back our view to front and let's turn on our grid. Okay, so now we are going to create 3 meter length of the edge, and let's do this 2D again here up to 2 meter, right? We're gonna have 3 meter, right? So if you observe on the left pop-up windows, we have 0 comma negative 2.5. So we're gonna have we we are going to set it at 0 comma negative 3, right? All right, so let's do this one. Okay, okay, so in either way you can do that. You can sketch another line here, or you can use translate, move this line into the x direction. So this is the x direction, right? With the value of 10. Okay, so the line of this dimension is 10 meter. So we are going to copy another one into here, right? So before you apply the new location of the edge or the line, so we can make a preview and okay. Okay, so where is your geometry keep inside the midasNFX? We have the 3 bar where you can see the model, the LBC, and the analysis. So the model means the geometry will be kept here. Okay, the mesh will be kept into the model tab. The materials, the properties will be kept into the material tabs. All right. LBC means boundary conditions. So all the setup about the boundary condition, like the fixed, the constraint, the load type, okay, will be kept here. And once you have run the solver and you have the result will be displayed over here. That is as simple as that. Okay. Okay, let's go back to the model. We have 3 lines. This is good. So we are going to create another line, which is 5 meter length with a distance of 2.5. All right. So let's turn on this one. So what I'm going to do is I'm going to create another 2D. Okay. Click one point, then you should have relative point. All right. So this is 5. So this is 3.5, 4. Okay, so it is easy for you to drag by using the mouse if your value is absolute value. So since that we are using 5, let's say if you have 5.18, okay, 6.12, okay, you have to refer and create, put into the this box, all right? So let's go to 5. Okay, that is done. We are not aligned perfectly. Okay, first let's check the distance. So the distance between this point to this point vertically is 2.5, right? So according to our dimension? Yes, that is correct. So we don't have to translate anymore. So we will check again. This 5 meter is sitting between the distance between this distance up to this distance. So this is supposed to be 2.5 with 2.5 distance, right? So that it can sit into the middle of the 10-meter symmetrical. All right. So make sure that this distance in the x direction to this distance in the x direction is supposed to be 2.5. So how you going to see that dx? This is the current distance. So our current distance in the x direction is 1.5. So we have to move it until 2.5. So we are going to move it 1 meter again to the left in the x-axis, right? Click, select your model to be translate. You're going to select translate into the x and with the value of -1. All right, so this time we are not going to copy because we're going to move everything in. And let's preview. All right, we will double check what is the x distance. Yes, perfect. And of course this is 2.5 as well. Okay. Sorry. Okay, so we will build the rest of the truss. Okay, this is here using 2D sketch. That's all. So we have already fixed point, and now it's easy for us to make a few new line. So this is the line curve. So we are not going to deal with surface. We are not going to deal with solid. All right. So as I mentioned, basically, when we are dealing with truss and beam, it is preferable to use line to model it. The first thing is it's easy, straightforward, and the second thing is based on the accuracy, it is much more accurate compared to 2D and 3D, according to our benchmark, according to our verification with the testing. Okay, so this is what we have done so far. So this is the model. This is the exact model from the presentation without the I-beam, without the pipe yet. So now we are going to select materials. Click on the materials, right click, add isotropic materials. All right, so you can access to this material windows with in any button as well. Beside of using right click with your mouse, you can go to the mesh, the materials. Then you can create isotropic. Then you should access to the same. All right, so let's maintain with this one. I'm prefer to use steel for the demonstration. Let's select from the library. So from the library, when you select the steel, you have all the parameter in. Let's say if you have different materials, okay? So yes, you can define your own. You can define your own materials as well, right? So I prefer to use the library first. Okay, by the way, just pause for a moment. Materials, you have different type of materials behavior: linear materials behavior, non-linear materials behavior, right? So linear material behavior means that it applies Hooke's law. F equal to kx is linear, right? It's linear at all. So like we when you're dealing with rubbers, okay, when you are doing the I would say that like non-linear materials, for example rubbers, for example like well steel is belongs to non-linear in some cases, all right. If you have applied a large loads, all right, so it behave non-linear. If you remember the stress and strain curve, all right, initially starting we're gonna have a linear curve. Then we have our ultimate strength, we have the yield strength. So that area belongs to non-linear. So most of the application in the industry belongs to non-linear. So they achieve at that particular region. That is why we have to use so-called non-linear elastic, all right, or elastoplastic when your materials reach to a plasticity for some reason. Okay, so keep simples with our demonstration linear and press OK. We have steel created. Let's close it. This is the new created steel, right? So I'm going to assign the steel to the lines or the wire or the edge. In order to do that, we have to create two things. We have to create the properties, all right? So the properties is actually the link between your materials into your line over here. However, the line will be represented in the mesh. Okay, I'll show you right now. First, let's create your properties 1D. So we are going to use bar and define the section. Um, Area of moment inertia, the torsional constant will be calculated automatically whenever you have designed the type of the beam or the bar itself. Okay, so let's use I-beam. Let's go back to our model. Let's put a little bit, right? Okay, so I'm using mm, 300 by 300 so these are all the dimension in the dimension 1. This is dimension 1, this is dimension 2, dimension 3, and etc. Okay, so I think this is straightforward. So what I'm going to do is, before I do that, just click, switch to my millimeter, create again bar section, and I'm going to use I-beam. All right, so I will refer to presentation. I have 300 by 300. This is 300 depth, 300. Dimension number 4 is 10, 15, 15. Okay, so this is the I-beam. So remember, the beam will be assigned to steel, so everything will be made by steel. So I just name this as beam. Okay, so this is the properties, right? So you cannot see the real geometry yet, like this one. Okay, until you generate the mesh. Okay, so I'm going to prepare another properties before I generate the mesh. I'm going to use the pipe. Sorry, I'm going to use the bar again. Assign, make sure that this is steel. Before I assign the section, let's name it as a truss. Okay, so in the truss, I'm going to use pipe. Pipe. No, there's no pipe, right? Just a moment. Where is the pipe? Okay, let me see. Oh, sorry, it's a tube. Okay, so we have another two dimension, all right? So this is the dimension, which is the outer radius. Dimension 2 refer to the inner radius, all right? So the outer radius belongs to 84.15, and the inner radius 79.15. So this is mm, of course, all right? Apply, check, check. Okay, so this is the beam. These are the thrust. Okay, so now I'm going to link between the materials with the property itself by using the mesh. Okay, so I'll be using the mesh. Now we are going to generate 1D mesh instead of 2D or 3D. So this project or this demo, we're focusing on 1D. Let's select a size, perhaps 2. Let's select the object. We're going to start with the beam. Then we are doing for the thrust afterwards. Okay, so the y-axis direction, right? So let's keep this one as, okay, so what is this? Okay, when we are creating 1D mesh, we need to supply one extra information and tell the software that the direction of the 1D mesh. The direction of the 1D mesh referring to the normal direction is not the propagate direction. All right. So if we are going to build a mesh along this line, all right, the propagate direction in this case is z-axis. All right. The normal direction in this case is x or y. All right. So let's use y. So means that let's activate 1, 0, 0. So by putting 0 or putting 1 means you activate in that direction, 0 means you deactivate in the rest of the direction. All right. Let's press OK. So this is the beam. I will rename this one as beam. Right. Okay. So I have put quite a number of mesh here. I'll just undo. I'll do it again. So instead of the size, so I put it as division. That means that there will be 2 mesh nodes only on that particular area. Again, 0, and this is the beam. So this is the properties. This is the properties referring to this one. Okay. And in the properties, remember and recall that we define the dimension of I-beam. We define the pipe dimension in the inner radius and outer radius as well. So these properties refer to the properties we have created in a moment ago. Okay, so if we selected the right properties for this mesh and we turn on, so you have the I-beam. Okay. Okay, so I think it's going to be very simple right now. We are going to create this mesh. Okay, we're going to create this mesh, and I'm going to put okay, let's put division, let's say 5, or let's put the size. It doesn't matter. So you investigate what is the size, the proper size. How you're going to determine the size? Simple but lengthy. All right. So first, so-called, you have to do this mesh independent study. Right. A mesh independent study is, initially you have to guess what is the size of the mesh. Right. Whatever mesh you put in, then you do a second simulation. You adjust the mesh, and third simulation you adjust the mesh. Of course, you have already the experimental data at the beginning of the simulation. You compare with the experimental data, and the mesh independent study, where you have to study different type of a different set of number of size of mesh with the result itself, and you have to plot a graph. Right, let's say you have 0.5 meter mesh, and you have this stress. Then you plot the graph again, 1 meter, and you have that stress, and again and again. Right, so this is where you do the mesh independent study until the result become stable. All right, so it will fall into a particular constant magnitude. So that is your final size of the elements. Okay, let's put 0.5, and this is thrust. Okay, so we have generated. Wow, this is huge because 0.5 is, sorry. So this is mm. So I was thinking that 0.5 is a meter. So I just put this one into meter, 0.5. Okay, so we don't have to modify the y element because the normal direction will be z here, or the y, all right? So it's fall onto the default uh, element axis. So this is thrust again. This is thrust. Okay, so I'll just preview. The number should be greater than 1. Oops, I'm sorry for that. Let's put to, oh yes, this is division, this is size. Sorry. All right, I'm putting to size. Yeah, that's good. So I assign the properties, thrust. Okay, so done. And let's switch on. So what you are seeing is not exists in the reality, but the solver will take these properties into the calculation. It's a mathematical modeling, right? Okay, so we have done the modeling. We have done with the steel. The mesh has been generated. You see that? This is the beam. This is the properties of the mesh beam itself. And we have the steel assigned and etc. Right? Remember, save your project. Okay, so I have a few clients, I have a few friends who does not like to save the project. And when the software crash, they have to reopen. So I asked them why. Why do you don't want to save the project? He says that I never save the project because I save the project in my mind. So all engineers knows what to do. Just funny, right? Okay. Um, okay, so what I'm going to do next, I have the pre-processing ready, all right? Of course, the boundary condition has to be there. Let's look back into our presentation. So now we are going to tell the software where is the constraint, where is the forces, and etc. Okay, this is what we are going to do right now. We are going to LBC, right? So since that this is a linear static, okay, so I'm going to put in the constraint. So I'm going to fix the constraint using advanced. Okay, so the reason why I'm showing you the advanced is that you can play with the constraint in 6 degree of freedom. So the 3 degree of freedom is the translation, which is the tx, ty, and tz, and another 3 degree of freedom belongs to rotational. Okay, xyz again, right? So I'm going to fix this one. Okay, so we are going to fix everything. So we are going to not to move everything into this bottom here. So observe here carefully. We can apply the constraint either on the point, edge, face, or nodes. Okay, so either one of the selection is okay. No problem with that. All right. So since that I have already activated my mesh, so let's switch off my properties. Let's turn off my geometry. So then I should be able to select. All right. So let's say if you do not want to select on the beam or on the mesh, so you want to select on the point, then we will turn on this one. All right. So what are the different, the point and the nodes? Okay. The point, the edge, the face belongs to geometry, which is belongs to here. Okay, so you can create the point, you can create the edge, which is the line or the curve. You can create the face, which I did not create. The nodes belongs to the mesh. All right. So in my practice, I prefer to apply on the point. All right, but in some cases you have to apply on the nodes. Right. Okay, so in order to apply on the point, you have to activate the curve. You don't have to switch on the mesh, no problem with that. So this is selection for in this area. So we have one here, we have another one here. So in fact we are not selecting the nodes, so we are not selecting the nodes, but we are selecting the end point of the edge. Okay, so let's say this is fixed. So you'll be seeing a representative of the fix here, and the information is kept into the LBC again, the boundary condition. Okay. All right. The next thing is the vertical force on the intersection between the truss and beam. Right. So we're going to the static, the force. So again, we can apply on the node. Okay, let's apply on the point, if I can do that. Sorry, just a moment. Point, this point. Okay, so we can turn off this one, right? So we're gonna have a magnitude of just 10 Newton. So I hope you understand why I'm putting minus. So this is Z, this is Z, positive going upwards, negative going downwards. So it's going to apply downwards, and I'm going to have a point. Sorry, this is, oops. So it doesn't matter. You can do it again. Point, select the point. You can drag and select, right? So it's when you select the point, so this is already filtered by the point. Okay, so minus 10. I'm gonna put this one as vertical force, and okay, see, so this is the magnitude of 10 Newton in the direction of negative Z direction. All right. Okay, the last but not least, I'm going to apply a beam load. All right. So why I'm putting the point load is because this is due to the weight of the truss, due to the some other weight, and the beam load can be a weight on the slab itself. All right. So that is why I'm putting a beam load. Okay, so I'm putting on the edge. Select the edge. So you can do a fractions. So let's go back to our presentation. So this is the beam load. Okay, so we are going to apply a fraction of uh, minus 1000, and the second way is minus 2000. So what is this? Okay, let's look at this one. This is 1 minus 1000. So what is this? Let's preview. Okay, so let's align our model. Okay, the beam load direction is into the Z preview. Okay, it's not obvious. I put a little bit obvious. I lower down the value, and even I lower down the order as well. So this is the beam load with the fractions, right? So it's a proportional from 1 point, which is W1, into the W2. Okay, so with the slope value, right? You can apply in any type of the force if you want. So you can apply with a constant, like say, you can put it 2000 if you have constant. All right. So in some cases, you may not have a constant load line along the beam, along the slabs. All right. So this is what you can apply. So the purpose of I'm using the element load or the beam load is to show you how you can apply the load on the slabs. If the if the load is not a constant value, it's not a, I mean, what we call that is a constant value along the slab itself, right? So you have different fractions. So you may use this one. So I would say that this one is a beam load, and okay, all right. So let's save it. Okay, so I guess we have done most of the work in the preprocessor, the mesh, the materials, the geometry, and the boundary condition itself. All right. So the next step is we are going to set up the solver. So we are going to analysis and result. Again, we can go to analysis as well to create the type of analysis. So in FEA, we have a number of type of analysis. We have quite a number of type analysis. I would say that a lot. Let's say if I drop down, these are different type of analysis we can do in FEA. Right, so for the moment we are not able to combine the solver or the type analysis, but we can do a wide range of analysis, independence analysis, for example, like thermal analysis, for example, like so-called the vibration analysis, and etc. Okay, so in our case it's very simple. We create linear static. Let's say just make a name, linear static 1 perhaps. All right, so look at these things. So we have offset, we have activate parts, okay, we have subsetting. So we are going to set up the solver as I mentioned, right? So initially we have something like that, okay, because you create the linear static, it's automatically select all your meshes, all the boundary condition and the loads, right? But I'm going to show you manually. I'm going to involve this mesh into my analysis. So what is default mesh? Default mesh, just forget about it. It's just nothing. It's just no value. So it's created by midasNFX. It has to be there, right? It has to be there. So forget about it. It's nothing. It's nothing to do with your case. Okay, so this session is the selective mesh for our next simulation, right? So you can select different type of mesh to be involved in the simulation, right? So in many cases, we are using this advantage, right? So we are trying to do a different set of mesh, okay? We test on different set of mesh, or we see what is the result, right? The boundary condition has been set up. We will select and drag here, select the loads into here, okay? So since we don't have to do any settings, so just leave it, just leave it, okay? Then just okay. You should see the LN1 has been created. Remember, save your project. All right. So yes, we are ready. Right click, solve it. So this is linear static analysis. We solve it within 0.3 seconds. All right. Okay, so what we are going to see here, we are going to see the result. But however, you are not seeing the result if I double click on this one. All right. The reason is you have to keep in mind the result is kept inside the mesh. It's not the geometry. Okay, let's go back to the mesh and geometry. You may look into the geometry. This is the geometry, the cat itself. All right. You may look into the mesh. So it is similar. It looks similar, but mesh contain equation, contain nodes. In each of the node, it has a set of equation. Okay, so means that when we are doing the simulation, we are running the solver, the equation will be solved within the mesh itself, not the geometry. So that is why you cannot see the result when you activate only the geometry but not the mesh. All right, so let's go back. Okay, so in order to view the result, all right, so in midasNFX, you have to turn on post mode, which is the post processing. Okay, so this is pre mode. All right, so whenever you have finished your simulation, it will automatically switch to post mode. That is why you were seeing just now some quantum of colors and etc. When you are editing with your geometry again, your boundary condition, your materials, you go back to the pre-mode. Okay, pre-mode means pre-processor. Post-mode means post-processing. So let's see the result and double click. We have the translation and let's align. So this is alignment. Align in front, align in back, the top and the bottom. So why I prefer to align when I draft the model into the Z direction? That is because I love this one. So I know that this is front, I know that this is top, right? It's easy for me. Then you should be able to see the bending moment. Okay, so this is the force bending moment in the Z. This is the force bending moment. No, we don't have that, of course. So the axial force and etc. All right. So what we what else you can do with the post processing is sometimes it's very important for you to look into the maximum and minimum value. Okay, for instance, like translation. Okay, so remember this translation, the unit is in meter. All right, we have 0.0024 meter deformation. But in this case, I prefer to use mm because is already to the power of -3. So if I'm using it's more appropriate, right? Okay, we have maximum here, we have minimum definitely, so there is no movement. We can amplify the result. Amplify the result means you can amplify the result. It doesn't mean that you will increase the deformation, but it's just showing you the more deformation result, auto skew. All right, this is not real, but this is real. Okay, because our deformation here, the maximum is 2.4 only. All right, 2.4 millimeter. And if we amplify, then it is good. In this case, it is good. If we try to include in your presentation, and if they are someone or the deformation is not obvious, you can increase, or 0.5, whichever you prefer, right? So this is deform mesh. I would like to include both deform and undeformed mesh. Right? So this is to show you how you can post-process your result. Okay, so this is not really a nice graphic, but if I do that, it's much more better. All right. Okay, the next thing what you can do is you can use the probe. Let's turn off this. Okay, you can use the probe. So as I mentioned, the mesh that generated contain the equation, and once the equation is solved, it contains the result. Okay, as simple as that. So what you are seeing here, these are all the nodes we have created from the mesh. So these are the mesh actually. So if we use the probe again, and if you point to the each node, what do you have? You have the node result. All right. So now the question is, we have created 0.5 meter mesh nodes, right? And what about in the middle? So the intermediate will be interpolate or extrapolate, right, between the neighbor nodes when doing the calculation or when doing the simulation. Okay. Um, we are using some terms here. So we are using a coarse mesh or fine mesh or intermediate mesh, right? So as I mentioned earlier, you will not know what is the size, the appropriate size to be used, right? So in this case, you may rely on this size, but who knows? You have to increase or reduce the size of nodes, right? Which means that you will have more nodes. So which will be appropriate? I don't know. You also don't know, but we have to perform another analysis, which is the mesh independent. Initially, I assigned 0.5 meter mesh size, right? So I have the result. I keep the result. Okay, I will do another simulation. I regenerate the mesh, and I will just reduce the size. Let's say 0.25 meter. So the distance is smaller, right? And means that we have more nodes, right? And I'll compare the result, all right? Okay, in this case, maybe I will compare with, I'm not going to do that, okay? But just imagine, I'm going to compare a 0.5 meter size nodes in terms of the displacement, compare with 0.25 mesh nodes size with the displacement. Okay, let's say I compare with the maximum displacement. Simple as that. Okay, what will be the result? So maybe the result is the same. So it means that I have already achieved a good mesh initialization. Or if the result is different, so you have to continue go on, right? Until you get a consistent or precise, I would say that precise post result, right? So well, I think you have a lot of question about mesh independence or something like that. So just let me know if you have any problem with that. Okay. What today our objective is very simple. So um, in order to get some insight of the software, in order to get some insight of how you're going to process from the pre-processor, the solver up to the post-processor, you are going to get an insight on how to create the model, the mesh, and the properties itself. and how to assign the boundary condition, right? So you have the idea, but you are not depth into that yet. Okay, no worry on that. So you're going to explore after that, right? Okay, let's say if you are using our software, let's say if you have already installed our software, okay, so this is important. This is for your practice. Once you have installed the software, the installation will by default into the C and program file and logs into the directory of the software installation. I'm using 2020 revision 1. Okay, and if you go into that manual tutorial, you have all the tutorial ready. All right, you have linear static. If you click, you can practice. You see, you have almost the same demonstration that I have done. You can refer to here. You have many tutorial you can follow. Okay, so this is linear static. So this is 2D, which I did not include. Right, you can follow you how you can create a 2D, how you can create a function, something like that. It's more advanced. Okay, so let's go back to the folder. These are all the manual in PDF. Okay, these are the model you may need to run your tutorial. See, this is the 3D model, the x underscore t that I mentioned to you, parasolid, the stat file, right? So if you refer to any of the PDF, so it will mention that which of the model to be used for your practice in your tutorial. All right. Okay, so I will just touch off this one. All right, so I think that is all the thing that I have to deliver. And okay, let's see if I have anything to do. Okay, I think that is all I have to deliver. Yes, Dr. Shakia. I'm waiting Dr. Shakia, so to see that if any of you have questions, then you may ask to me. Yes, I think, yeah, Dr. Shakia.
Hi.
Hi, Dr.
I
Shakia.
think they have one question here from Muhammad Iksan.
Okay.
He asked about display for hue, force diagram, and bending moment diagram
Oh, okay. Diagram. So,
on the result visualization.
yes, you need a diagram, right?
Yeah, what
Oh,
kind of this one?
okay. Then, perhaps I will prepare that. I need to prepare that, and then, perhaps Dr. Shakir, you can share to your student how you can how he can actually create a diagram. So I'm not ready with that yet in this
All
model.
right, okay.
Okay. So I just write down the diagram. Okay.
How about the other student? Do you have any further questions? Please ask, because this is the only opportunity that you have to interact with the one who has ability or on a MIDAS software.
Yeah. Any one of you can feel free to ask. Or
Student from
yes.
student from 5C5, 5A3, 5A1. My student.
Okay. Okay, I see one of the chat here. Okay. Okay, so we are focusing on 1D. So is there any different on the procedure if we are using 2D? Okay, that is good question. Yes, if you are doing for 2D, or I'll proceed with 3D. 2D or 3D is much more much more I would say that you have to do some work also, right? The process flow is still the same. All right, you select your property, you select your materials, right? where you're doing here is the same as well. So you select your materials. If you're working on 2Ds, you will add a 2Ds, okay, whether it's membrane or the plate, then you have size thickness. Okay, let's say you're working on the slab itself, so the thickness itself. Uh, this is what you have to define. Then you will create a 2D mesh. Okay, you create a 2D mesh, so that means you have a surface already. All right. So instead of 1D, then you have a 2D surface. Boundary condition remain the same. The solver remain the same as well. All right, it's nothing different. So it's just the model. So if you're dealing with 1D, the wire, you have to create 1D properties and using the 1D mesh. If you create 2D, you generate 2D, you create 3D and 3D. And the last question, yes, you can combine 1D, 2D, and 3D. But since that you have different type of dimensional mesh, you have to ensure the 1D and 2D or 3D are connect properly. Okay?
Right. In the chat box, we have another question that can we save the info PDF into the PDF format from Radia?
Uh, so you want to save it into PDF from Radia.
Yeah.
Okay, what do you mean by that? You want to save the result into PDF or you want to get it from the Radia?
No, no, no. The Radia is name of student.
Oh, okay,
She
okay. I'm
asked.
sorry for that. I was thinking of the software. Okay. Yes, yes, yes. You can save it into PDF. So we are actually utilize the 3D PDF here. Okay, let me see. Where is it? Others? No. Just a moment. I can see that. Okay. You can use a. Okay, you can see that.
Oh,
All right, so you can export into 3D BTF. Okay, what is 3D BTF? I think most of you know, but I think some of you may not know. In order to export into 3D BTF, and you have to open with the full version of Acrobat Reader, and in the 3D BTF, you have the ability to rotate the model. You will see the result. You will be exploit the model, and it works like same environment in the CAD and also the midas. You can see all the result, the stress, the bending moment, and etc. So this is the export into PDF, but it is in the 3D format. Okay. But if you want to export the result, but you don't want to create your own report, you want to rely on the midasNFX report. So it's a Microsoft document, so you can create report. This is the wizard to create the report by itself. So it's not PDF, it's not 3D PDF, but just the report. You have extract, you have the mesh, and etc. Just like what you're trying to create in the thesis.
okay.
Okay.
Right. I hope that it's clear to you, Radia. And
Yep.
then the next question is, can we transfer the drawing from AutoCAD to the MyDesk software?
Okay, so AutoCAD, you have quite different version of AutoCAD, right? You have Inventor AutoCAD, you have 2D AutoCAD, right? The answer is yes. If you're using 3D AutoCAD, like Inventor, you can export the 3D Inventor AutoCAD into the dot parasolic, the X underscore T, okay? Let's say if you are using 2D AutoCAD, yes, you can do that, but you will be importing wireframe. All right. When you import the wireframe, you have to clean it up. So you will go here. So this is import DXF. Okay. This is so-called the AutoCAD format. It's just wireframe. All right. In the normal importation, basically we are dealing with 2D or 3D. So we use Parasolic, ASCII or step file, and you may see that Inventor. Okay, I believe that Inventor is working on most of on the 3D. All right, so this is 3D, 2D. So either you're working on 1, 2, or 3D in the Inventor, it can be import directly. Okay, let's say this is a little bit different. If you're using AutoCAD, this is the option you are importing the wireframe. So the answer is yes.
Yes, it's possible.
Yes. Okay.
Then they got like one more question. How can we install the software?
Okay. So installation of the software is just straightforward. Just double click the execution. So I'll show you. So there are two things to be installed. So okay, I'll show you the installer. Company. We have Midas. So midasNFX. I have the installer. Okay, so it comes with the WinZip or WinR. So you have exe file. So it's just normal installation. Once you have installed already the software, you have to set up your license. Okay. There are a few types of licenses you can utilize. So for student, you'll be going for the web license. Okay. Web license mean something's like a series key or series number, but you have to connect to internet in order to use your software. You have to connect the internet always if you want to use MyDataNetX, right? So if you have the series key provided by me, then I'll show you the step. I will provide you the PDF or something like step how you can actually put in your series key and activate your license. It's simple, straightforward. Okay. All right. So what else we have? Um,
I think, yeah, another one is I want to ask, is it difficult to install this software in our laptop? I think we already answered this one. And what the step, how big is it? And can any laptop install this software? Thanks in advance. I believe that you already answered this one
yes,
on
yes, yes.
installation.
Yeah, because I believe that most of our laptop is come with i3, i5, or i7's processor where you have a dual core, quad core, something like that already, right? So yes, it works. It works on your laptop if you have that specific processor by the Intel. About the RAM, all right? So you have to be careful with the RAM. If you have 4 gig with the RAM, yes, it's sufficient, but if you work with 1D like what I'm showing you here, yes, it's sufficient. But if you create more mesh, more RAM required. All right, I'll give you some guideline. Let's say if you want to create 1 million of mesh nodes, you need at least 1 gig of RAM. All right, so if you have already 4 gig, you have to remind that 4 gig will be utilized by Windows, by all the services, by Midas interface, and etc. I think you left about less than 1 gig. All right, so if you run 1 million mesh, okay, and it will hang your computer. So at least you have to upgrade your RAM. All right, depends on the number of node or the size of the project you're going to handle. Okay.
Right. I have one more question. Is there any limitation on the web license on number of nodes or number of elements?
Uh, Okay, not for the moment. For the web license, there is no limitation. There's no limitation, but the only limitation that you are going to have is you're going to okay, let's say if UITM already purchased a license, all right? You're not going to have a limitation if you are using student license. Yes, there will be limitation of the number of nodes up to 100,000. All right, so if you are intend to use for your project, all right, I'll be providing a so-called trial commercial license, which is unlimited. You can use as much as you want. Okay, but the limitation is only for 30 days, but it can be extended lah. So it can be extended. Okay.
Um, and then there is a question that how about installation? I think we already answered this one. And we need internet during the installations and
Yes.
during the running of the software. We need.
Yes.
And where we can install, I think we already answered this one. And second question, since you have said that 1D provider provides better result for trusses compared to others that I mentioned, why is that? Is there any particular reason for it? Thank you. Thanks in advance.
Okay, definitely. When you should have this document once ever you have already installed the software. So this document is very important document for accuracy of the software. All right. So let's go to the installation directory, the manual. We're gonna have verification manual as well. Okay, so what is this about? This is about the benchmark. So the benchmark is done between our company and a NAFEM company, whereby NAFEM company basically they are trying to set up the experiment jig, okay, based on a certain experimenter. And in our side, basically we are trying to set up the modeling, right? We are going to compare between our simulation result with the real experimental result, right? So from this result, okay, so you may notice that the result, one of the result here is dealing with 1D and with 3D as well. We did a comparison. So as a summary, basically the 1D result is more lying to the experimental result compared to 3D experimental result, right? So if you look into this benchmark, all right, it is very important for as a user when you're trying to model something. So how you're going to know you're going to use 1D, 2D, or 3D? So how you're going to know you're going to use the element type? Okay, there are many element type in midasNFX. All right, so you may refer here. This is the experimental result, for example. This is the simulation result. So you can make a merge. You can make a comparison. So which is the best? So I hope this will answer your question. Okay, so we have another question, right? The last question from me is there any tips or tricks, especially to fasten the procedure in using this software, like maybe pressing any keys or something like that? Okay, what do you mean by fasten the procedures? You want to cut short the procedure? You want to, I mean, skip some procedure so that it will be fast enough?
Or
If
might be
sorry.
simplified any simplified
Yes,
elements
yes,
or
yes,
something.
yes. Initially, I did mention that this software is for expertise in FEA. Is also for the beginner for FEA or non with any non-engineering background as well. Okay, so how you going to do that? Let me show you. Wait, also, I have a lot. So let's create a new. Okay, so this is my new. Okay, let's turn off everything. Yes. Okay, so before I start with any new shade, let's look at my mouse over here. You have designer mode and analysis mode, right? Let's compare the number of tape here and the number of icon. Okay, so you can see that with the designer mode, it's much more simplified compared with analysis modes, right? In analysis mode, you can create many geometry. You can modify or manipulate your mesh. So in the designer mode, you are straightforward. So you are guided by the wizard, right, to do the analysis, right? So this is where you can start if you are a basic user for FEA. Okay, so yes, you can do that.
Right. They got like several more questions here. The
Yes.
one more is from Amira. Is it possible for us to see the real life work, big infrastructure that Sir CJ will have done? I think like
I think
patient.
it's not today. So the real world is not it's not with me for the moment. I have my workstation in my office. Okay. I think I have a few real works that is coming to my mind on the tunnel modeling, right? The tunnel modeling with the hard rock, soft rock, with the lining. Okay, I have done that. I think I may plan to upload into my website, which is the academic.newmeet.com.my, whereby you can explore how actually you can model the real things or the real world activities throughout my courses. All right. So I'm sorry, not for the moment. I'm come with my laptop today, so all my cases basically store into my workstation, right? But stay tuned into our website academic.newmeet.com.my. Then I think you should be able to explore more in the futures.
All right, one more question is like, does this software can produce an output like in a video format?
Yes, definitely. You can provide. It depends on what type of video you are trying to do. But both, yes. So what do I mean by what type? Means that whether you have a static or you are transients, right? So transients mean you have a time independence, and static means your time independence is equal to zero, right? It's nothing. So let's show you something like that to see the result. Let's activate the properties again, and let's see the result. Okay, let's see. Right, so this is not a real video animation, but you can see at least something like that. All right, so you're going to export, save it, AVI. Okay, you're going to save it as AVI. All right, then you will have, yeah, you have your AVI over here. Okay, so you can export, yes. Okay.
Okay, one more question coming from here. If the license is expired after 30 days, is it possible to again install extend by using the similar ID that we first registered, or we have to use?
Yes, yes. The series key will be reused again for your extension, right? But you have to tell me, because sometimes there are a lot of requests of this trial. You have to share with me. You may send me an email. You share with me your series key. Then I will ask our headquarter in Korea to extend your license.
And then they got like almost similar question here. I think
Yep.
or the answer where to use 1D, when to use 2D and 3D. What's different in the result?
Okay, in trust beam frame analysis, usually we use 1D, and most of the cases we use 1D. Why? Because it's much more precise, accurate, and it's much more simple. All right. I did some real life case study whereby I have a reinforced concrete, where inside the concrete I have rebar. So the rebar, basically I can do it in 1D analysis. Okay, but there are special requests where they would like to see the crack, the break, or the damage of the rebar. All right, the crack and damage of the rebar cannot be done in the 1D, cannot be done in linear static. So it has to be done in the dynamic analysis. All right, so for the rebar, it cannot be modeled as a 1D. It has to be modeled as a 3D. All right, so in 3D you may able to see how the rebar is breaking off under certain ultimate loads. Okay, but for frame analysis, usually we prefer to use a 1D. For slab analysis, we prefer to use 2D. All right, but it depends on the cases. That is the normal practice. All right, hopefully I answer your questions.
Yes, depends on the situations and the output that we want.
Yes.
Then lastly, from Aisha, what kind of info we need to know to do the modeling? I think this is in the pre-processing on the geometry.
What kind of info, right?
Yes.
Okay. First, you need to have your geometry dimension, right? You need to have your 3D model or 1D model. Okay, what is 3D and 1D? So we have 1D model in a 3D environment in my demonstration. Okay, so what is that? 1D means you have line, edge, and 1D refer to the geometrical. All right, so 2D means refer to geometrical, you have surfaces. Okay, 3D means you refer to geometrical, you have solid. All right. I'm sorry. What was your question again?
She's asking, what is the info needed to maybe to start the modeling?
There is a lot of info like dimensions. Okay. You need to have an exact dimension of your model. All right. You need to have so-called the boundary condition. So the boundary condition is where you have to observe on site. So where to be fixed, where to be unfixed, and how the movement is expected to be. Okay, so this is very important and this is very lengthy, right? So you need to equip quite a number of patient, okay, in order to observe how the boundary condition works. All right, so sometimes the boundary condition works where you do not constrain every of the degree of freedom, right? In my case, I constrain all of degree of freedom because in some degree of freedom, in some boundary condition, you have to release some of the degree of freedom in the actual situation because of the physical is not limited movement in that particular area. So this is very important, and this is you need a lot of patience to observe. So how the boundary condition. If you put a wrong boundary condition, you will get different result. So in other words, rubbish in, rubbish out. All right. So you need to have boundary condition. You need to observe the right possible loads. All right. And you have to know what type of materials is used for that particular frame or whatever things, right? That is what you need to have. Of course, the dimension, you have to start with the dimension. Okay.
From Zul Hazik, I think there are several questions regarding this one.
Mm-hmm.
Can we get the slide from Mr. CJ? I think this session is recorded. You can watch back this session.
Yes.
Then is there somewhere that show a list of all equation in the notes?
Well, there is, but you have to refer to manual. Again, we go back to our installation directory, program file. So in the manual folder, you have everything. Okay, you have the benchmark, this one. Okay, the tutorial and the analyst manual. Both it include both. One's for the CFD, one for the FEA, the structure analysis. In this manual, you'll be able to explore how we utilize the based on the category, how we actually make use of the equations. All right, how we set up and etc. All right, so this is some of the matrices in the for the element. Yes, you can find most of the detail from this manual. Okay, once you have installed the midasNFX.
Okay, another one question is, for the registration, can we use UITM email? Sure, I think.
You have to use UITM email if you have, or if you do not have, you can ask for your supervisor. If you still don't have that, you let me know. Okay, so I will try to process with you. Okay.
Must use from our official email
Well, as long
UITM.
as your supervisor or your lecturer can confirm that you are one of their student, yes, you can do that also.
Okay.
All right.
So I believe that I already read all the questions, and to the students, you still, if you have a question, please drop here.
Yes.
Slope stability. One more question. Another question: is it possible to calculate the slope stability?
Yes, it's possible. Yes, it's possible. I do not have my demo. I did once slope stability with SESB in Sarawak, which is the electricity provider in Sarawak. So they want to do the slope stability. Yes, it has been set up in my midasNFX, but unfortunately, I do not bring my case. But I believe that I will be uploading the courses into the our website also in the coming days.
All right.
Yeah.
Further, I think one more question here.
Yes. Stability.
Is there any words from the panelists, which is the lecturer who teach this subject,
Um,
Dr. Adiza? Words that, oh, you have more question here?
yes.
Um, think, no, one more. So one more question. Can Start Pro to do this analysis as well? If can, then which one is recommended for the FEA?
Can Step Pro do this analysis as well? If can, then which one is more recommended? Well, it's up to you. It's up to you. It's up to the application. Most of the user, I found that a lot of user is using Step Pro. A lot of user is using midasNFX. However, I would say that midasNFX has more wide range of applications compared to Step Pro because midasNFX can do much more, including the CFD, including the so-called the slope analysis and etc. And always remember that Midas is born from a civil engineering background. All right, Midas is born from a civil engineering background, and the developer is from civil engineering. Whereby in the Midas company itself, we have developed more than 20 modules of FEA software. Midas NFX is one of them. We have like Midas Civil, Midas Gen, Midas FX, and etc. Okay, so if you are dealing with civil engineering, most of the user prefer to use Midas to do the analysis. Okay, but however, Step Pro, yes, there are a lot of people like to use Step Pro as well, but it depends on your application and your requirement. All right, so for example, like CFD, has CFD anything to do with civil engineering? Have you thought about that? Yes, I have done quite a number of analysis on CFD, the fluid analysis on civil engineering. The stay bridge cable stay bridge, right? So one of the client basically they would like to understand how the lift and drag force affect to the cable stay bridge, right? So that is one of the crucial part. And another client basically is looking for CFD for so-called the vortex vibration for the bridge as well, for the high-rise structure. Okay, so CFD is related to civil engineering. Okay.
Right. One more question is that what's the difference between Midas and Abacus, and which one is more convenient for the beginner?
Well, it's hard for me to answer your question in such a way that I start with Midas
Depends.
and FX, so it's not fair for me to tell you that yes, NFX is straightforward, is easy to use, and all those things. It's not me to answer your question, but you can explore. You can explore, but I will guarantee that Midas and FX has all the feature that you required. Okay, in civil engineering, not only for structural, not only for slope analysis or seismic analysis, or you can model the tunnel in the midasNFX. You can also do quite a number of simulation. So for myself, I prefer to use midasNFX, but in some cases I cannot use midasNFX because it's limited in some area. So I have to switch to different software. So lastly, each software has their, their own string. Okay, so it has their own string.
Okay, I got one more question here. Does the Midas software provide example of various tutorial in the
Yes,
website?
not in the website, but in the
Mhm.
local hard disk. Once you have already installed, you have various of tutorial. So how various is it? Okay, for example, like linear static. Linear static is the one that we have done. Model analysis, I'm not sure you're going to involve that. Is the model analysis of the so-called the frequency analysis. You may need to have seismic. Okay, this both. Okay, seismic analysis, nonlinear expresses. Sometimes that, let's say an aircraft is hitting to high-rise building, so what will happen? So you may need to use a nonlinear explicit analysis. Okay, so you have all the tutorial inside, including the CFD as well. You can also use the CFD with your license. Okay. Okay, so the next question is,
No more, I think.
so okay,
Oh, one more. So Midas software is in need in civil engineering companies. If I am proficient in using Midas, is it an added advantage for me in order to me to be a structural engineer?
yes,
Sure.
definitely, Definitely, yes. If you mention Midas to any civil engineering company, most of them they will recognize about Midas. They knows about Midas. Okay, especially JKR. All right, so they
Mhm.
knows about Midas. They have been using Midas for quite some times. Okay, so I would say that if you equip with FEA knowledge, okay, you can involve in any industry. All right, you can go for civil
Mm.
engineering company, you can go for mechanical company, you can go for automotive, aerospace company, any company will want you. All right, because you know FEA, right?
Okay.
All
I
right.
believe that
Yes.
questions is a very advantage knowledge to you, added value to your resume, for example.
Mm-hmm.
No more question, I think.
So it's not refresh.
So
Yeah, I
then
think
I'll go.
yes, I think we may miss one question. Can you provide us the link to install the software for student? Well, the link will, I think I will pass to your supervisor. All right, then your lecturer or your supervisor will be passing to you in order to install the software. All right, so that is how it works. You cannot download from the any website yet for the moment. So we do not open, but we will share the link to you.
We are towards the end of the session.
Yes.
Students, do you still have any questions? If not, uh, we are going to end the session soon.
Okay.
I think no more questions at this moment. Um, so we would like to say, oh, got one more.
Is
If
there any certificates regarding Midas software? Okay, it depends on what you are referring to. Are you referring to a training certification or the software itself? Okay, I'll answer you both. By for the software itself, it has certification like ISO certification. The software has been certified by ISO standards. No worry on that. Midas has been used worldwide for civil engineering. If you go into the Midas website, you will see that a lot of project has been done. The Burj Khalifa, for example. Okay, so the Korea, the Korea Bridge as well. All right, the Benes Stadium in China. So they have been used. So which means even Midas doesn't have certificate, it already proved that Midas works well worldwide. All right, it has certificate for ISO, definitely. If you're referring to training, yes, if you are going through our training for 2 days, not for 2 hours, 2 hours is too short for use. If you go for 2 days training, yes, you'll be provided, certified certificate for you to use the software. Okay. Okay. Any more questions?
so, any questions from panelists? Okay, that's all for me.
Okay.
So I
Thank
think
you.
Muhammad.
Yes. Thank you. Thank you very much.
Okay, all right. From our side, from UITM, we would like to thank you, our speaker,
Yeah.
Mr. CJ, today
Yeah.
for
Thank you,
making
Dr.
time
Shakir.
during this
Thank you, Dr.
during
Shakir.
this Christmas holiday. You're supposed
Okay.
to
Okay.
have
And
a good holiday.
yeah, you do
Next,
enjoy your holiday after that, all right? Okay, thank you very
yeah.
much. Nurul Husna, thank you very much. Nurifa Zana, okay, thank you very much. What's that? From Muhammad.
A very good
Yes,
exposure for us.
yeah, all right, thank you very much. Okay, so I think Dr. Shakir would like to end for this. Thank you, Wasni.
Yes.
Yes,
So they are saying their appreciation here. I
yeah,
think a lot of thank you, about 400 later.
thank you, Adiza. Thank you, Irfan. Yeah. So I think in the future, if you plan to use the software or whatever, so you just I think Dr. Shakir will be arranged for them, right?
Yes,
They intend to do that lah.
and all the panelists.
Yes, yes, no problem.
Thank you so much, Mr. CJ.
Okay, thank you very
For
much.
uh, you are very good, and based on your experience, that you have explored a lot of areas, not only civil engineering, but also mechanical. As you can see that all your example here.
Okay, all
It's
right.
good.
I hope a short training for 2 hours can help you all in your project, and I hope that good luck for your project as well. And I really hope that you do enjoy using midasNFX if you have the opportunity. All right. So okay, so thank you Novahana, thank you Anis, thank you Norizati, thank you Shani, thank you No Kamila, thank you Shafiq. Okay, okay, Merry Christmas to everyone. All right. Thank you, Faris. Thank you.
Yes, was. All
Okay.
right.
All right.
Yeah, we'll
Okay. Thank you,
end the
Ravi. Yeah.
recording.
All right. Okay. So thanks a lot. So I will quit right now.
All right. Thank you, Mr. CJ.
Thank you. Bye bye. Happy New Year.
Happy New Year.
Yes. Bye.
Bye.
Okay.
Happy New Year.
Okay. Bye bye.